Okay, so good morning. Today we will be checking. Sydney Fish Market for a design estimate project for plumbing trades. So let me share my screen. So as I've said, this is the kind of structure that will greet you whenever you are assigned the project. It's three folders, pre-proposal Excel. It will be like this. You have multiple Excel sheets, and then project files. You have these folders. Arash will most likely upload all of them here. You can segregate them a little bit here and organize them for better. That's up to you. And for SP proposal drawings, this will mainly be empty and you will fill this up. So first, let's review the drawings. Let's check the architecture. So I'm providing this perspective for you because sometimes you won't always get hydraulic plans for plumbing. Sometimes you will get stuff like this. You will get stuff like architectural. And what's important here is the sections. This can be useful. Examples like this can be useful when you need to calculate for a seismic factor for an estimate project. I mean, it's not that needed, but if you need it, at least it's here. So what we can get from here we can see that you have concrete soffit, which will deliberately have an effect on the BOM or material takeoff. Since if it's concrete, we're going to have to use seismic anchors. But going to here, we can see that apparently we also have some timber and we also have some non-structural soffit here. This is concrete again. Okay, so sure, let's play with that. Let's just post this. Okay, hydraulic designs. Let's review this first. Okay, so you can see it's mainly pipes. Here you have a bundle of pipes. You have tanks. You have horizontal tanks here. Okay, you have big pipes. Okay. Okay. So I want you to take note of plumbing pipes. For plumbing pipes, especially for drainage and stormwater, unlike mechanical, where we assume that the pipes are always filled, here we would assume that the pipes are 50% filled. In reality, the pipes for drainage are not always filled, unlike let's say the mechanical ones or the fire ones, they're not always filled. So when you're calculating for weight, especially for plumbing pipes for drainage and stormwater, you can assume 50% of it is filled, 50% at capacity. However, for pressure pipes, you can go 100% for pipes that have cold water and hot water. So let's move on to his work actually. So first, let's open this one. Okay. Okay. So here is his work. It's quite a lot, but we'll focus on the notes for first. Okay, so as discussed before, Arash will provide the importance level on the planner. So why don't I show you? So this is New Sydney Fish Market, right? New Sydney Fish Market. Let's see. Okay, oh, apparently it's not here. Okay, so it's not here. Alice is very open to the chat. You can ask him right away. So yeah, if it's not in the planner, you can coordinate with the project manager. And in this case, you can coordinate with the project manager. So let's get back to the rules. So for the rules, it's a bit similar to the mechanical ones. Be mindful of this first three rows. for importance level 4, pipes less than 32 on bundle of trapeze that weigh 15 kilogram or more, you have to count them. If even if they're small, the size doesn't matter anymore since they are sharing a trapeze, and you have to consider that group of pipes. The size doesn't matter at this point. If they are bundled, just remember that the weight is more prioritized than the size of the pipes if they are bundled. If they are bundled, you check if it is more than 15 kilos. If it's more than 15 kilos, you have to count them. Another thing is for importance level 2 or 3, pipes less than 65, you have to count them essentially. For 65 and more, for importance level 2 or 3, if the pipe is less than 65 and it is singly hang, it is not to be considered. But if it's more than 65 singly hang, you have to consider it. For importance level 4, since this is a bit of higher importance, if it's greater than 32 mm singly hang, you have to count it. Now, what I wanted to show you here as well is this one. Essentially, these are factors in which pipes are grouped. Say, two pipes less than 65 next to each other that cannot be on the same trapeze. Only measure one length. Sorry, two pipes less than 65 next to each other that can be on the same trapeze. So let's say you have two pipes, or let's just use this example. Three pipes less than 65 next to each other that can be on the same trapeze. You measure one length, say for example these two, you measure just one length and you multiply that length by 1.3. That's how you do it if there are three of them. If there are two of them, 1.2. Just remember that. So just take a note, just take a look at this table right here. It's essentially complete. Complexity factor, this is for your own judgment, and pipe size factor, this is pretty self-explanatory. If the size falls within this range, then it's 1. If it falls within this range, it's 1.1. If it's 200 or more, it's 1.2. So pretty self-explanatory. If you go here, easily, as you can see, Jose did a wonderful job. He also included some of the factors here. I just want to show you 4 pipes, 2 pipes that include 65 or bigger. So this is 2. When runs gonna be the same support, it should be 1. So for this last row, for essentially pipes that are not on the same run, let's say they are one is of higher elevation and one is lower, you can do with measuring each length. You can assume that both of them are singly hanged. Okay, so let's get back to this. Let's check his work. So as you can see here, it's predominantly linear measurements. Just want to take note, say for example here, you have 4 runs and you only counted 1 run. So that's an example of multiple pipes in a single run for plumbing. Actually, that rules also applies to other piping projects such as fire and mechanical. It's also listed in their notes. So yeah, please take note of that. Also have this. I think this is roof mounted. Oh, okay. What did I want to show? Okay, so for pipe projects, you can see some of them are here. You can see some of them are here. This will become relevant for the sole purpose of, say for example, you go back to basement. If you are in basement and you can check this, you can see here that some of the pipes we are looking at for drainage, they are below. For drainage, you are looking at below. So if you see drainage or stormwater pipes here, you can assume that it's below You can assume that it's below basement. But if you see pressure pipes such as hot water and cold water, you can assume that they are above or on the under slab of the next level. So if you see, let's say, say this one, cold water line, you can assume that it is under the under slab. If you can check, if you can see that it's drainage pipe, it's below. So yeah, that's usually how it goes. I think this is importance level 4. Okay. So let's go to the MPO ones. These are a bit more important. So for MPO, essentially, this is where we put our markups with materials. So here it's more of accounting. 750. So for VSP1, we have 3 variants actually. We have 3 variants for VSP1. Just a sec. Okay, so this one, and this one. We also have this one. Let's swap them a bit. So here. Okay, so oh, by the way, this wasn't counted because it was I think this was concrete or underground. Yeah, something like that. Okay, so just want to show these two. So VSP, they have a small number here. This indicates that this is the maximum hanger height they can support. VSP1 can support up to 750 mm hanger height. This up to 1 meter hanger height, and this up to 1.5 meter hanger height. Just note that if the VSP can go deeper, essentially it's more weaker. So the highest capacity here is this one, and the lowest capacity is this one. Um, Now you have another variant here. So I can explain this, and actually, let me just show you the detail. Mhm. This is how they look like. So you use this serves as a two-way support. This serves as a two-way support for multiple pipes that share a trapeze. This serves as a four-way support for multiple pipes that share a trapeze. So if you recall our explanation between two-way and four-way, essentially four-way, it can catch lateral and longitudinal forces, while this one can only catch one direction. This one, however, this one can support four-way and two-way. So if you look back here, or if you look what Mr. Jose has prepared for us, it is essentially a it is essentially this is acts as a four-way, so it's good to be used in intervals, and it's expensive to use this one for this case because we do not need a horizontal member. We can use this one for this case. Just a note, you cannot use this if the trapeze or if the soffit you are hanging them off is not concrete. If it's steel, then it's no good. If it's steel, you should use definitely wires. So that's the case. And let's go check out the roof for this one. Check the roof. Okay, so if I recall correctly, for roof, what we did here is, as you can see in the previous, as I have shown you before previously, this had wood for horizontal members that support the roof. So what we do is, first we use this, and afterwards we had to quickly change them because I think they sent the architectural drawings a little bit too late, and we had to change our quick design, and we had to use this ones, the wire systems. Wire systems are pretty much flexible, although sometimes the client don't prefer them. They're actually like the second most choice for clients. Usually what they want is, I mean, there are clients that prefer wires, but in ideal situations, the wall-mounted restraints are the best ones. Second are these, and I say the wires are the third. So just keep that in mind whenever doing estimates. The first priority is to check the wall. The second priority is to use the soffit. So if the wall is perfectly fine, if the wall is structural, then all good. So yeah, see this one, we use the wall first, and the wall can support multiple runs of pipes. Okay, so I think we are good. So let's check the MTO. Let's check what he prepared for the MTO for us. Mhm. Here it is. It's an Aussie strut, VSPR Aussie strut, by the way. So yeah. Oh, okay. Another thing is, I forgot to mention, there are certain situations in which you cannot use this because of the hanger height restrictions. It only can go up to 1.5. And as you can see, the wire restraints can go deeper than that. So what we did is here, for the higher levels in which we used wires, we opted to leave this out and use wires instead. So as you can see in the BOM, I think we changed this up a bit, or okay, my bad. So I think what we did here is we opted for the one, since it can carry. We opted for the 1.5 since it can carry that. And yeah, I think for in this case, if I recall correctly, we opted for this one because the client preferred it, and these are much easier to install. So it's an upside for them. And we forego the wire, we let go of the wire because we found out that this one is sufficient enough for those higher level pipes. So I think I've explained how to input these. Well, this is an old version of the MTO. I think I've explained how to input these. Essentially, just consider the hanger height and diversify as much as you can, especially for the others. So here, you don't have to put them all in 750. As you can see, there were 1.5. So I think this is good enough for plumbing. Thank you.